Hello guys, welcome to question 4 of our final exam preparation series, and this is more trig related questions that we'll be handling, and we are definitely going to talk about identities, general solutions, and things like that. So let us have a look at the first question. Here you go. Okay, so the ideal situation that we want is to always deal with one trig ratio, okay? However, if there are two, in this case, sine and cos functions, we'll need to creatively eliminate one by using the identity tan theta is equal to sine theta over cos theta, okay? So we have this. If we divide both sides by cos theta, okay, and put in the restriction that cos theta is not equal to 0, we know that we have this now. Okay, so that is what we have. Tan theta is equal to 1. What is our reference angle? It will be 45 degrees. Okay, what is the period of the tan function? We know that to be 180 degrees. So therefore, the general solution is 45 degrees plus k, 180 degrees, and k is an element of integers. Okay, so this was straightforward, and definitely it is, easy marks to get. So, good. This takes care of the first question, and we are going to the second question. Take a look. All right, so we are now proving an identity, okay? The rule of thumb here is to always start on the side that has the most number of terms, so that you can do a lot with that particular side to get to the other side. How do you determine whether or not you're on the right track? Is that you'll always be given a complex identity, okay? And you must end up with obviously a simpler type of expression. So you always go from difficult to easy, or from complex to simple, all right? Not the other way around. Otherwise it becomes heavy for the mind and you will tend to give up on that particular question, all right? So let us see what's going on here. We have a fraction equal to a fraction. Cos 2 theta is equal to cos theta minus sine theta. Definitely going to start on the left hand side because that is where most of the stuff is happening. Okay, this gives you an idea because one of the identities here for the double angle of cos is cos squared theta minus sine squared theta, and somewhere somehow the factor with a plus has disappeared. We'll see what happened to that one. Okay, and we are moving from that to 2 cos theta, so we need to eliminate a sign, and also when we expand this into its equivalent expression through the identity, we'll need to pick the right one because there are 3 choices, remember, for the double angle of cos. Okay, so this one is straightforward. So the left hand side, we have 2 sine theta cos theta. That is for the first term here, plus what will be the relevant one here? 2 cos squared theta minus 1. Okay, that is for that. We still have the constant there, plus 1 over what? Okay, cos squared theta minus sine squared theta. We're moving in that direction. Okay, so what then do we have? Cancellation happens here, and we have a 2 cos and a 2 cos that we can factor out. Okay, what is left? We are left the sine theta in the first term plus a cos theta in the second term over the difference of 2 squares factorized into cos theta minus sine theta. Sorry, this becomes a cos theta plus a sine theta. Now, the light bulb moment. Now we see what happened to this guy, right? That is what we see. And this is equal to 2 cos theta over cos theta minus sine theta, which is equal to the right-hand side. Okay. Clean mathematics, and this takes care of this particular question. All right. Let us look at the next question. Okay, in this question, we are asked to find out the values of theta for which the identity is invalid. Okay, it will be invalid if we divide by 0. So where is the problem? It's right there and right there. Okay, so if cos 2 theta is equal to 0, okay, and cos theta minus sine theta is equal to 0, then the identity will be invalid. Okay, so where is this happening? We'll need to find the reference angle here. Cos inverse of 0 is 90 degrees. Okay, so if 2 theta is equal to 90 degrees, we know that theta is equal to 45. So cos of 90 degrees is definitely equal to 0. And if you divide by 0, it will be invalid. Is that the only solution? No, we also know that at 270 degrees, it is undefined. So if 2 theta is equal to 270 degrees, we can still work with 270 because we're given a domain of 0 to 180 degrees. But we divide by 2 now to get that theta is equal to what? 135 degrees. So we have these two solutions so far. Let us see that side. We know that it will give us tan theta equal to 1, reference angle equal to 45. It's definitely that one. Okay, so where theta is equal to 45, but where else? Theta will be 180 plus 45 degrees because tan of an angle is positive. We're in the third quadrant. We're going to take that solution? No. 225 degrees is outside the domain that is given of 0 degrees to 180 degrees. So theta is an element of 45 degrees to, not 2, 45 degrees and 135 degrees. Okay, that's why we use curly brackets and not round brackets. Okay, good stuff. We are done with question 4, and this will take care of an extension of trig from question 3. We're now heading off to some Euclidean geometry questions, proofs, some riders, some intricate problems there, and they'll be very interesting to interact with. So I believe you are ready for that. I'll see you in the next segment that will be uploaded soon. Thank you for tuning in. See you on the other side. Keep well. Sharp, sharp.